Assalamualaikum and good morning everyone. My name is Madam Najwa and today I will be presenting Chapter 1, Overview of Technology Maturity Model, also known as TMM. In this chapter, we will learn what the Technology Maturity Model is, why it is important, and how it is used to measure the development stage of a technology. So, let's begin. In this chapter, there are three main topics that will be covered. First, Section 1.1. Understanding the scope of various activities in the Technology Maturity Model TMM. In this section, I will explain the meaning of the Technology Maturity Model TMM, its fundamental concepts, and the various activities involved at each stage of technology maturity, from the research and development phase to the stage where the technology is ready for commercialization. Next, Section 1.2. Study the social and economic impact of emerging technology at different TMM stages. In this topic, I will discuss how emerging technologies affect society and the economy at different stages of the technology maturity model. The discussion will include aspects such as improved productivity, employment opportunities, innovation, and the challenges that may arise during the technology development process. Finally, Section 1.3. The characteristics of disruptive technology. In this section, I will explain the key characteristics of disruptive technology, which refers to technologies that have the potential to transform or replace existing technologies by providing more innovative, efficient, and impactful solutions for industries and society. Now, without further delay, let us begin with the first topic, understanding the scope of various activities in the Technology Maturity Model TMM. Alright, now let's move on to the first subtopic, which is understanding the scope of various activities in the Technology Maturity Model TMM. First, the advancement of technology will continue at an unprecedented speed. This means that technology is continuously evolving at a very rapid pace. Today, we can see many emerging technologies such as artificial intelligence AI, the Internet of Things IoT, blockchain, robotics, and cloud computing developing rapidly. These technological advancements have transformed the way we learn, work, communicate, and conduct business. Second, it is difficult to fully understand the impact of a new technology. This means that when a new technology is first introduced, it is not always possible to predict all of its effects. Initially, we may only notice its benefits, such as increased productivity and improved efficiency. However, as the technology becomes widely adopted, we begin to recognize other challenges, including cybersecurity threats, data privacy concerns, changes in employment opportunities, and broader social and economic impacts. Third, consider the possibilities of billions of people connected together. Can you predict the future? Imagine billions of people around the world being connected through the internet. With smartphones, social media, and digital communication platforms, information can be shared instantly across the globe. Because technology evolves so rapidly and is used by billions of people, it is extremely difficult to accurately predict how it will continue to develop and shape our future. As we discussed earlier, technology is advancing very rapidly, and because of that, it is becoming more difficult to predict its future impact. Therefore, we need a model or framework to guide us in understanding and evaluating the development of technology in a more systematic way. That is why this slide states, thus, we will need some generalized model to guide us. In simple words, this means that we need a general model that can be used as a guideline to evaluate the maturity of a technology, identify its strengths and weaknesses, and determine whether it is ready to be implemented or commercialized. Next, what is a model? A model is an abstract representation, description, or definition of a structure, process, or information. Simply put, a model helps us understand something that is complex in a simpler and more organized way. It does not show every detail of the real situation, but it focuses on the important elements so that we can better understand and analyze a system or process. For example, the Technology Maturity Model, or TMM, is a framework used to measure the maturity level of a technology. It shows how a technology progresses from the early idea and research stage through development and testing until it is finally ready for implementation or commercialization. Alright, now let us understand what is meant by a maturity model. As shown on this slide, a maturity model is a model used to assess the current stage or effectiveness of a process within an organization. In other words, it helps an organization understand how mature a process or technology is and whether it has reached a satisfactory level of development. Besides that, a maturity model is often used as a guide for continuous improvement. Once an organization knows its current maturity level, it can identify the areas that need improvement and plan suitable actions to achieve better performance in the future. Furthermore, a maturity model helps organizations make decisions about the steps that need to be taken to reach a higher level of maturity. It provides a systematic approach by describing the best practices and processes that should be followed to improve the development of a technology or business process. For example, if a company wants to develop a new technology, it can use the Technology Maturity Model, or TMM, to determine whether the technology is still in the research stage, the development stage, or whether it is ready for implementation and commercialization. This helps the organization make better decisions, reduce risks, and improve the chances of a successful project. Alright, now let's move on to another maturity model known as the Capability Maturity Model Integration, or simply CMMI. CMMI is a process improvement model developed by Carnegie Mellon University in 2006. It is designed to help organizations evaluate the maturity of their processes and continuously improve their efficiency, quality, and overall performance. The main purpose of CMMI is to provide best practices and guidelines that organizations can follow to ensure their processes are well managed, consistent, and effective. As shown on this slide, CMMI focuses on three main areas of interest. The first area is product and service development. This area focuses on the process of developing products and services. It includes activities such as planning, designing, developing, testing, and improving products or services to ensure they meet customer requirements and quality standards. The second area is service establishment and management. This area focuses on establishing, delivering, and managing services effectively. Organizations need to ensure that their services are properly planned, monitored, and continuously improved so that customers receive high quality and reliable services. The third area is product and service acquisition. This area focuses on acquiring products and services from external suppliers. It involves selecting the right vendors, managing contracts, and ensuring that the purchased products or services meet the organization's requirements and quality expectations. Alright, now let's look at the 5 levels of the Process Maturity Model in the Capability Maturity Model Integration, or CMMI. Each level represents the maturity of an organization's processes. As the maturity level increases, the organization's processes become more organized, effective, and continuously improved. Level 1, Initial. Let's begin with Level 1, which is the initial level. At this stage, the organization's processes are unpredictable, poorly controlled, and reactive. Most activities depend on individual skills and experience rather than on standard procedures. As a result, the outcomes are often inconsistent, and the organization may face difficulties when dealing with unexpected challenges. Level 2, Just Managed. Next is Level 2, which is the Managed level. At this stage, the organization starts to plan, manage, and monitor its processes more effectively. Each project follows a basic management process including planning, tracking, and controlling. Although the processes are still project-based, they are more organized compared to Level 1. Level 3, Defined. The third level is Level 3, which is the Defined level. At this stage, the organization has well-documented and standardized processes that are used consistently across the organization. Employees follow the same standard procedures, although these processes can still be tailored to meet the specific needs of different projects. This helps improve consistency, quality, and efficiency. Level 4, Quantitatively Manage. Next is Level 4, known as Quantitatively Manage. At this level, the organization measures and controls its processes using data and performance metrics. Important information such as project cost, completion time, quality, and productivity is collected and analyzed. This allows managers to make decisions based on accurate data rather than assumptions. Level 5, optimizing. Finally, we have level 5, which is the optimizing level. This is the highest maturity level. At this stage, the organization focuses on continuous process improvement. It regularly uses feedback, innovation, new technologies, and data analysis to improve its processes, increase efficiency, reduce risks, and deliver higher quality products and services. As shown on this slide, the CMMI model divides organizational maturity into 5 different levels. Each level represents how well an organization manages and improves its processes. As an organization moves from one level to the next, its processes become more structured, more efficient, and more effective. For many organizations, especially those involved in product development, the main goal is to reach the highest maturity level, which is level 5, guess, optimizing. At this level, the organization does not only follow standard processes, but it also focuses on continuous improvement. It regularly evaluates its performance, adopts new technologies, learns from previous experience, and looks for better ways to improve quality, productivity, and customer satisfaction. However, reaching level 5 does not mean the work is completed. After achieving the highest maturity level, the organization must continue to maintain its processes and make regular improvements. This is because technology, customer needs, and business environments are constantly changing. Therefore, organizations must continuously review, monitor, and improve their processes to remain competitive and successful. Alright, now let's move on to the Technology Readiness Level, or TRL. Technology Readiness Level, or TRL, is a framework used to measure the maturity of a technology. It helps researchers, engineers, and organizations understand how far a technology has progressed from the initial research stage to a fully operational system. As shown in this diagram, TRL is divided into 9 levels, and these levels are grouped into 3 main phases. The first phase is basic technology research, which includes TRL1 to TRL3. At TRL1, the basic scientific principles are observed and identified. At TRL2, the technology concept is developed, and researchers begin exploring possible applications. At TRL3, experiments and proof of concept studies are carried out to demonstrate that the technology is technically feasible. This stage is mainly focused on research to prove the feasibility of the technology. The second phase is technology development, which includes TRL4 to TRL6. At TRL4, the technology is validated in a laboratory environment. At TRL5, the technology is tested in a more relevant environment to ensure it performs as expected. At TRL6, a prototype is demonstrated in a real or simulated operational environment. This phase is known as the technology demonstration stage, where the technology is developed and validated before moving to the next phase. The third phase is system or subsystem development, which includes TRL7 to TRL9. At TRL7, the prototype is demonstrated in an actual operational environment. At TRL8, the complete system is fully developed and tested to ensure that it meets all technical and operational requirements. Finally, at TRL9, the technology is fully proven, deployed, and operating successfully in a real-world environment. This is the highest level of technology maturity, where the product or system is ready for commercial use or full-scale implementation. Alright everyone, now let's take a closer look at the Technology Readiness Levels, or TRLs, based on the European Union framework. The Technology Readiness Level, or TRL, is a measurement system used to evaluate how mature a technology is. It consists of 9 levels, starting from basic scientific research and ending with a technology that is fully developed and ready for commercial use. Now, let's go through each level one by one. TRL1, Basic Principles Observed. At TRL1, Researchers observe and study the basic scientific principles behind the technology. At this stage, the work is mainly theoretical. It involves paper-based studies, literature reviews, and scientific observations. There is no prototype or product yet. TRL2, technology concept formulated next, is TRL2. At this level, the technology concept is developed. Researchers begin to identify possible applications of the technology. However, these applications are still speculative, meaning they are ideas that have not yet been tested or validated. TRL3, experimental proof of concept. At TRL3, researchers develop an experimental proof of concept. Laboratory experiments and initial testing are carried out to show that the technology is technically possible and has the potential to work. This is the first stage where the technology begins to move from theory into practical research. TRL4, technology validated in the laboratory, moving on to TRL4. At this level, the technology is validated in a laboratory environment. Researchers perform more detailed experiments to collect evidence that the technology can achieve the expected performance under controlled laboratory conditions. TRL5, technology validated in a relevant environment. Next is TRL5. Here, the technology is tested in a relevant environment, which is closer to real-world conditions. A semi-integrated prototype or model is developed together with supporting components to evaluate how well the technology performs outside the laboratory. TRL6, technology demonstrated in a relevant environment. At TRL6, a working prototype is successfully demonstrated in a relevant or simulated operational environment. This means the technology has become more complete, and researchers can verify that it performs as expected before moving to real-world testing. TRL7, system prototype demonstration in an operational environment. Next is TRL7. At this stage, the prototype is tested in an actual operational environment. This allows researchers and engineers to evaluate the technology under real operating conditions and identify any remaining issues before commercialization. TRL8, system complete and qualified, moving to TRL8. At this level, the system is fully completed, tested, and qualified. All development activities have been completed, and the technology meets the required technical and operational standards. This stage represents the end of the development process. TRL9, actual system proven in an operational environment. Finally, we have TRL9, which is the highest level. At this stage, the technology has been fully proven in a real operational environment. It has been successfully tested, validated, and is now ready for full commercial deployment or large-scale implementation. This means the technology is no longer an experimental project but a complete product or system that can be used by customers or industries. In conclusion, the Technology Readiness Level Framework provides a clear roadmap for technology development. It begins with basic scientific research at TRL1 and progresses through concept development, laboratory testing, prototype validation, and operational testing until reaching TRL9, where the technology is fully mature and ready for commercialization. By using the TRL framework, researchers, universities, industries, and governments can assess the maturity of a technology, reduce development risks, make better investment decisions, and ensure that a technology is ready before being introduced to the market. Alright, now let's discuss an important question. At which stage can we estimate the cost of a technology? The answer depends on the technology readiness level, or TRL, because the accuracy of the cost estimation improves as the technology becomes more mature. At the early stages, from TRL1 to TRL3, it is very difficult to estimate the actual cost of the technology. This is because the technology is still at the research and concept development stage. Many aspects, such as the design, materials, and development methods, are still uncertain. Therefore, any cost estimation at this stage is only a rough estimate. When the technology reaches TRL4 to TRL6, the cost estimation becomes more reliable. At these stages, prototypes have already been developed and tested in laboratory or simulated environments. researchers can begin estimating development costs, material costs, testing costs, and maintenance costs based on the prototype. Finally, at TRL 7 to TRL 9, the cost estimation becomes much more accurate. At these stages, the system has been demonstrated in a real operational environment, and most of the design has been finalized. Organizations can calculate production costs, operational costs, maintenance costs, and commercialization costs with greater confidence. Therefore, if someone asks, at which stage can we estimate the cost of a technology? The answer is that an initial cost estimation can be made starting from TRL4. However, the most accurate and realistic cost estimation is usually achieved between TRL7 and TRL9 when the technology is close to commercialization. In conclusion, the higher the technology readiness level, the more accurate the cost estimation becomes. This helps organizations make better financial decisions, reduce investment risks, and prepare the technology for successful commercialization.